Hello, welcome back to our series on Embabel Framework. Until now, we covered the basics of Embabel Framework. Then we created two simple AI agents. One was based on Shell and another one was based on the REST API. Today in this tutorial, we will be focusing on one of the important concepts, which is how to use the conditions in case of Embabel Framework. Let's say if we want our agent to take different path of execution based on certain criteria, that is where the conditions comes into the picture. It is just like the if and else block that we usually write in case of any programming language. Now let's quickly understand the use case that we are trying to achieve here. So we are going to build a very simple e-commerce based AI agent which deals with the product replacement as well as the refunds. As an input, user will provide the product ID. Also, user will describe the problem that they are facing with that particular product. Then our AI agent will see if we have the replacement unit in stock. If we have the stock of that particular product, in that case, the replacement will be issued. If the product is out of stock, in that case, the customer will receive the refund. So this is how the overall flow is going to look like. First, user will send the post request to our application. This request will be received by the controller. Then controller will invoke our e-commerce replacement agent. Then agent will see it can achieve one of the two goals, that is it can either issue the replacement unit or it can issue the refund. But in order to achieve that goal, first we need to check whether the product is in stock or not. That is where the two conditions comes into the picture that we have defined. Check whether the product is in stock or it is out of stock. So based on the outcome, one of the goal will be achieved. Either the replacement unit will be issued or refund will be issued to the customer. Once the decision has been made by the AI agent, the decision will be forwarded to the controller and controller will send back the response to the user in the form of JSON. Now let's jump into the IntelliJ. So our application is going to be the Spring Boot based application within which we will be having one controller class to accept the request from the user. Then we will be having our agent. And then in order to work with the LLMs, we have defined certain configurations. And then we have the set of DTOs that are going to be used throughout our application. So now let's start with the pom.xml first. Here we are making use of Spring Boot version 3.5.7 and the Java version that we are making use of is the 21 and the Embabel version is 0.3.0 snapshot, which is the latest version available while recording this video. And if you are looking for the stable version, so at this stage 0.2.0 is the stable version which is available. Coming to the dependencies section, here first we have added the Spring Boot starter web dependency which will help us to create our REST APIs. And in order to work with the Embabel framework, we have added the Embabel agent starter which will bring all the required dependencies for creating the AI agent. Then we have added the Spring Boot starter actuator dependency which will add the observability features within our application. Coming to the repositories section, here we have defined the two repositories related to Embabel. First one is the Embabel releases and the second one is the Embabel snapshot. Now coming to the application YML, here we have defined the name of our application. Then we have defined the default model that will be used by the Embabel. In our case, we are making use of the GLM 4.5 Air version, which is the free LLM model available via the Open Router platform. Then we have defined the logging level, wherein we have kept the logging level as debug for the AI related logging. Then we have defined the configuration related to the Spring Boot actuator, wherein we are enabling all the endpoints that are provided by the Spring Boot actuator. Now coming to the application main class, this is the standard Spring Boot main class within which we have added one additional annotation, which is the @enable agents, which will enable the Embabel framework. Also, it will register the Embabel agents that we have defined within our application. Here we have added one configuration related to the application logging, and in our case, the logging will be done based on the Star Wars theme provided by the Embabel framework. Now let's quickly see the configuration that we have defined for working with the different LLMs. In our case, we are going to make use of the Open Router platform, which provides access to more than 400 models. And in our case, we are going to make use of the free models that are offered by the Open Router. So here we have defined the configuration class named as configure Open Router models. This class will extend the OpenAI compatible model factory. Now Open Router platform provides the APIs that are compatible with the OpenAI standard, due to which you will see our configuration class is extending this OpenAI compatible model factory class. And here we have defined the Open Router domain. Then we have specified the API key, which will come from the environment variable. Then we have defined the path suffix for the chat completion endpoint provided by the Open Router platform. And then we are specifying the observation registry, which is provided by the Spring Boot actuator dependency that we have added inside the pom.xml. Now within this configuration class, we can define the beans of different LLMs. Here we have defined the three beans. First one is for the Mistral 7 billion parameter model, another one is for the DeepSeek R1, and the third one is for the GLM 4.5 Air. So this is how we have to define the bean for the LLM. In our case, we have defined the name of the model, which is the GLM 4.5 Air. And since this is the free model provided by the Open Router platform, you will see the tag as free here. Then we have defined the pricing for these models. Since these are the free models, we have defined the pricing as 0.0 for input as well as the output tokens. Then we have specified the name of the provider. In our case, it is Open Router. And then we have specified the knowledge cutoff date. In this case, we have added the knowledge cutoff date as 2025 May 28. Now let's go through the controller class that we have created for accepting the user request and for sending back the response. So the name of the controller is e-commerce controller, within which we have defined the base path as API v1 e-commerce product. Then we have created one post type of endpoint with the path suffix as /replacement for dealing with the product replacement and the refund scenarios. And in order to accept the request from the user, we have created one Java record named as replacement request, within which user will provide the product ID and the problem description. And once we have received the request, it will be forwarded to the appropriate agent, and agent will return back the final decision that was taken. In order to send the response back to the user, we have created one Java record named as final decision. It will contain the decision code as the replacement issue for replacement scenarios and refund issued for the refund based scenarios. Then it will contain some user friendly message based on the decision that was taken by the AI agent. Once the user request is received, we need to forward this request to the appropriate agent that we have present inside our application. That is where the agent platform and agent invocations come into the picture. Now agent platform provides the environment within which our AI agents can run, and also it manages the lifecycle of all the AI agents that we have created inside our application. And in order to invoke our agent invocations come into the picture. So here you will see we have created the object of agent invocation class using the agent invocation builder. We have specified the agent platform inside that. And then we have specified what kind of output that we need. In our case, we need the output in this format. So we have specified the final decision class as the output type. And then we have configured few optional parameter, like if we want to log the prompts that was sent to the AI model, we can configure it using show prompts configuration. Then we have also enabled the show planning, which will log the planning that was done by the Embabel AI agent, and also we are logging the responses that are received from the LLM. Now once the agent invocation object is created, we need to invoke the agent. For this we have the invoke method, within which we are passing the request that has been received from the user. And once AI agent has completed the processing, we will receive the final decision type of object as the response, and which we will finally return it back to the user. Now, based on the type that we have defined inside the build method, in our case final decision, Embabel will automatically decide which agent returns this type of output. So in our case, we have created only one agent inside our application, which is the e-commerce based agent. So only that particular agent will be selected. If there are multiple agents defined inside our application, Embabel will see which agent returns the final decision as the output and accordingly invoke that particular agent. Now coming to our main AI agent that we have created, the name of the class is e-commerce product replacement agent. And then we have defined the AI agent using @agent annotation, within which we have given the name to our AI agent as e-commerce product replacement agent. Then we have defined certain metadata using the description and the version attributes. Now our AI agent mainly deals with the product replacement use case, in which two outcomes are possible. Either the product replacement will be provided to the user or refund will be issued. So these are the two ultimate goals that can be achieved. And in order to define them, we are making use of annotation @achieves goal. First one deals with the replacement scenario. Another one deals with the refund scenarios. Now, how agent will decide which goal to achieve? That is where the conditions comes into the picture. Replacement will only be issued if the product is in stock, and refund can only be issued if product is out of stock. So in order for replacement goal to be achieved, here we have defined a precondition as that the product should be is in stock, which is nothing but here we have defined the name of the condition that should be satisfied. Similarly, for refund scenario, we have specified the name of the condition that should be satisfied. That is, the product should be out of stock. So in order to define the conditions, we are making use of @condition annotation. So in our case, there are two conditions, that the product can be in stock or it can be out of stock. So here you will see we have defined a two condition. First one for checking whether the product is in stock. Another one for checking whether the product is out of stock. And these conditions are nothing but the normal Java method that we have written, which returns the Boolean type of output. Whether the product is in stock, it will return it as true. If product is out of stock, this particular method return the value as true. Now, in order to decide whether the product is in stock or it is out of stock, we need the inventory status type of object. Now, how this can be achieved? For this, we have created one new method and we have defined it with the @action annotation. What this method does is it checks the product inventory whether the mentioned product is in stock or not. Based on this, it will create this object inventory status and it will be forwarded to these conditions. Now let's go through each of these method in very detail, starting with the check inventory. So as an input, it will receive the object of replacement request, which is nothing but a request sent by user containing product ID and the problem description. Then it checks the inventory to decide whether the product is in stock or not. Inventory is nothing but the Java map that we have created containing the product ID and the number of available units. So here we are simply making the get call to decide whether the product is in stock or not. If the number of units is greater than 0, we will consider that the product is in stock. Once the decision has been made, we will create the object of inventory status, within which we are specifying the ID of the product, and then we are specifying the Boolean value stating whether the product is in stock or not. Then we have defined the two conditions. First one says whether the product is in stock or not. Another one says whether the product is out of stock. So here as an input, we will receive the object of inventory status that is created here. Here we are simply checking whether the Boolean field is in stock contains the value as true or false. If it contains the value as true, which means the product is in stock, this method will simply return the value as true. If the status is out of stock, in that case it will contain the value as false, and this particular method is out of stock will return the value as true, stating that the product is out of stock. Now coming to our issue replacement goal method, as an input we will receive the request sent by user just to log the product SKU ID. Then we will also receive the instance of AI provided by the Embabel. Using this we will interact with the LLMs. So since this scenario deals with the replacement, here we are making use of LLM and then we are specified the prompt as inform the customer that their replacement unit has been ordered and will be shipped soon, and also make the decision code as replacement issued. So here we have defined the prompt. Here we are making use of the default LLM which is provided by the open router GLM 4.5 air, and then we are simply stating the LLM to provide the response in this format, which is the final decision containing decision code and the final message that will be sent back to the user. Similarly, for refund scenario also, we have defined the prompt accordingly, stating that the product is out of stock due to which the refund has been issued, and the final decision code will be refund issued. So the response will be sent in this format only, final decision. So this was the AI agent that we have created. First, we will test our application, then I will explain you how the overall flow is getting executed. So I'll quickly start our application. So I'll clear the logs. Now coming to the postman, here you will see we are sending the request to the replacement endpoint, and while sending the request we have specified the product ID as headphone 01, and then we have specified the problem. Now before sending the request, if we see our inventory, the available quantity for headphone 01 is 10, which means the product is in stock. Now when we will send the request, our AI agent should respond with the replacement issue since the product is in stock. So here you will see we have received the response accordingly stating the replacement has been issued. Similarly, if we try to send the request for the product which is out of stock, in that case we should get the message related to refund stating that a refund has been issued for that particular product. So here you will see for keyboard 05 which was out of stock, the refund was issued. Now I will quickly explain you how the overall flow was executed. So when the user sent the request to our application, it was received by this controller. Controller forwarded the request to our AI agent. Now the AI agent thought that there are two possible outcomes that can be achieved. First one is related to replacement, another one is related to refund. But before we can decide which one to execute, these are certain preconditions that should be satisfied, which is in stock or is out of stock. But these conditions need the object of inventory status. That is where the controller came here. So check inventory will be executed first, and inside this we have defined the post attributes, which means after the check inventory is executed, these two conditions is in stock or is out of stock will be executed, and then based on the output returned by them, one of the goal will be executed. So now if I go to the uh, postman, and if I send the request for the scenario which is out of stock and the refund should be issued, accordingly the plan should be drafted by the AI agent. So here you will see it is ready to plan from the current state. When the request was sent, only the request sent by the customer was available, due to which replacement request object is shown as true, rest of the things are shown as false. Now initially it formulated the plan for the replacement, for which it decided that I will execute the check inventory first, then issue replacement will be executed. So here you will see the check inventory was executed, and then the condition was executed which mentioned is out of stock as true, and inventory status was also written by the check inventory, that is where the inventory status is mentioned as true. Now since the replacement cannot be issued because the product is out of stock, it needs to change the plan. So this is where you will see it has formulated the new plan saying issue refund needs to be executed instead of the issue replacement. So that is where you will see the final plan contains the issue refund method was executed, and the value that was written was the final decision. That is why it is also mentioned it as true. And since this scenario was not related to replacement, here you will see the issue replacement method was not executed and it is mentioned as fault. And the final response that the end user received was the refund issued and stating your product is out of stock and refund has been issued. So this is how the overall flow works. Yeah, so that was all regarding the conditions in Embabel. For this, we have also written the detailed blog which you can go through if you are interested. Also, the example that we discussed in this tutorial is uploaded on GitHub. You can simply check out your code, add the open router API key and try to execute the same. So that was all from my end. I hope you found it useful. Thank you.